The last part for the measurement of the staircase structure is measurement for the bar reinforcement. Okay, basically in the staircase measurement, we are referring to the bar reinforcement. We normally did not have the fabric reinforcement. Do you still remember what is the difference? Number one, the clause is definitely different. Okay, if you refer to the clause for the bar reinforcement, the clause is referring to F.8. This is the main difference. If you have another category of the reinforcement, for example, the other one is fabric reinforcement. Fabric reinforcement is referring to F.9. So that is the difference in terms of category and the clauses. Okay, now look at this sketch or look at this drawing. The first sketch here to show that the layout that are different in terms of the design. If you look at on the top here, this is the incorrect design by the engineer. This is the correct design by the engineer. Okay, a first principle that I would like all my students to understand is when you see the design by the engineer, the bar reinforcement must be overlap. Okay, must be overlap means if you look at the first design that is incorrect, you can see that there is no overlapping of the bar reinforcement between the bar inside the slab and the bar inside the staircase. Principally, the bar must be overlapped between at least two different items or different component in that particular element. Okay, look at this correct design. Okay, if you look at the layout, I use different color. Maybe red color. You can see here, this is the bar reinforcement until here. So this is actually belong to bar reinforcement in the landing slab. But even though this one belong to landing slab, you can see it is overlap with the bar reinforcement or with the component inside the staircase. Same goes to this bar. If you look at this bar, this is the bar inside the landing slab, but it is overlapped with the steps or in the staircase. The bar that is installed, I rub again, you can see the bar that is installed along the way inside the staircase is considered as the bar inside the staircase, like this one. This is inside the staircase, but you can see the bar inside the staircase is overlapped with the bar inside the landing slab. That is the principle that I would like every student to understand, principle of the design. Okay, right. If you look at the photo on your right hand side, this is one of the design for the bar reinforcement inside the staircase and also at the side of the staircase where you have something like this. The design for these two are different. Yeah, if you look at this one is empty, but this one is covered with something. So you have the bar that is horizontal, you have the bar that is vertical. Okay, now if you refer to the principle of the measurement, all the bar reinforcement is measured in, what is the unit of measurement, class? For the bar reinforcement, basically in kg. But you cannot simply get the answer in kg. What you have to do, measure in meter first. Then at the end, use the conversion bar calculation. Then you can get the actual quantity in kg. Thank you very much. Tubing heat Z and coverage. Okay, now this is actually the recap session. Before we go to the actual measurement for the staircase, you have learned this one before, but I would like to show also the design of the bar reinforcement that is maybe possible to be seen again in the maybe landing slab, maybe landing beam, especially in terms of the bending. Okay, this is actually a recap, but in Malay. But you can see I already convert the formula in English in our next slide. Okay, basically if you look at the introductory, this is the length that we have to measure in A. Okay, and then here is H plus A, this one H plus H, and then this one N plus A, the other one is 2N plus A. So if you see this one again in any drawing, you should know, okay, which formula I have to measure for the band, except if the length of A and H is already been given, then you can follow that measurement. Let's say the length for this band, you can see the design, but the band this one, the band is not be given. You only be given with the list and the formula. So you should know which one, list and the design. So you should know what formula that you need to use, because this is actually standard. We look at the first one where I make it bigger and already change to English, because the books that I refer here is in Bahasa. Okay, look at the first one, design in this one. Okay, so basically the length of this part you can scale, or either the length is given, but the length of this band is not being given. So you can see here the minimum band is H plus 90, H that is 90, and the total band can be this one. Okay, look at this, 4D, and then this one 3D, and this is 4D. So it can be 9D, it can be 12D in total, depends on the formula. Sometimes the specification in the drawing, they show you the formula. Sometimes you have to refer to any reference to make your own assumption. Okay, so it depends. If not being given, then you can make this lecture as the component for your queries or for your assumption lecture. Look at the second design. This is actually very common, and you have seen this one in the landing beam. Okay, the total band for this one can be minimum of 5D and can be the maximum of 6D. Okay, and if you are given the scale, then you have to scale from this length to this length and deduct concrete cover on the at the bottom and concrete cover on the top. For example, let's say you are given the actual size of the beam like this, and if you need to measure the length of this one, we may not have to consider this formula unless you are given the formula. So you take the whole depth, for example, 300 mm depth of the landing beam, deduct one concrete cover and deduct one more concrete cover, so you get the balance. Okay, next one. Okay, next one, this is almost similar like the previous one, but you can see that the minimum band is different. The first one has the minimum band of 9D, but this one has the minimum band of 11D and can be up to 15D in total. Okay, and this one, previously you can see 5 and 6, but this one can be the total band up to 9.5D. You can see I put star because this one can be changed according to the design. Okay, so in order for the QS to pick assumption list, you can refer to this specification. That means your assumption must not be on this. If you want to make assumption that minimum band is 5D, then it's acceptable. But you cannot make the assumption that the band is 4D because that is beyond the specification. Or you cannot make the assumption that is 11D for this design, for example. So refer to any reference or specification that have been shared or maybe you are experienced with before. How to get 15D? How to get 15D? You have to total up. 4, you look at this, 11 plus 4, you get 15. Okay, or maybe this one is not being given, or this one can be scaled, so you take 4D plus 11 and plus 4, but basically this 15 is actually come from 11 plus 4, so you get 15. This is one example. Okay, Dinesh? Right. Now, let's go to the measurement principle. There are 4 basic measurement principles that I would like you to remember, especially in identifying, okay, how many items that you have to measure and what are the category. Okay, so you can go back to refer to your SMM. Classification of the bar shall be as follow. We have to refer to F.8.4. The main clause that you have to refer is F.8. Okay, you can refer to your SMM. F.8, can all of you refer to your SMM section? Can all of you refer to your SMM section F? Okay, look at the clause in F.8. What is the title? What is the title before F.8? you can see the word reinforcement, and F.8 is bar reinforcement. Okay, the clause that we normally have to refer is F.8.1, kind and quality of the steel. Kind and quality of the steel is normally referring to what? Either mild steel or either high tensile. Okay, for clause F.8.B, C, and D, B, C, and D, sometimes you have to write down, sometimes you don't have. Okay, look at F.8.1, kind and quality. Please take note, this is considered as basic knowledge that you have to know. Number one, we have either mild steel. What is the symbol for the mild steel class? R or Y? R or Y? R is mild steel. Sorry, capital letter, yeah. And another one should be high tensile. High tensile. So high tensile is referring to Y, or sometimes you can see T. T is normally deformed high tensile, that is normally having more rough surfaces compared to Y. Okay, so Y is more expensive, and of course the abrasion between the concrete is better. Okay, so these two are actually clearly stated in F.8.1. A. That is the meaning of kind and quality. Kind and quality also referring to the size, because you have to mention the size normally in diameter before you buy and order from the supplier. Diameter, the size in diameter. Okay, another one, you also have to identify the kind and quality in terms of the texture, whether this one is plain, whether this one is used as the straight or straight and bend, or whether this one is used as the circular, or maybe circular stirrup. Circular stirrup means circular, or maybe this one is used as helical. So all of these also have to be identified, okay, and mentioned in proper way. Okay, and then in terms of the category, you can refer to F.8.4, but this one has the subclause F. You can see the word in step, staircase, and string. Okay, who will delete my sentence? Right, what I would like to highlight as well, you can refer to your SMM under F.8.6. F.8.6 mentioned about horizontal bar and vertical bar. Okay, horizontal bar and sloping not more than 30 degrees from horizontal, or that is over 12 meter. Can you refer to F.8.6? Shall be so described, stating the length in further stages of 3 meter. I guess all of these have been mentioned in your measurement one, but this is like a recap because we have to measure all of these by in different element. Principally, the rule of measurement are similar. You have to refer to kind and quality. That means either mild steel and high tensile. You have to refer to the size. You have to refer to the texture. Okay, and this is maybe applicable in your previous measurement and may not be applicable before. But what I would like to highlight is, if the length is more than 12 meter and the sloping is not more than 13 degree from horizontal, as what have been shown in your SMM, okay, not more than 30 degree from horizontal. But if the line is over 12 meter, you have to write in stages of 3 meter. Okay, what is the meaning of this sentence? The meaning of this sentence is, let's say you have very long straight flight, especially if you refer to, I think, the Afri building in Japan that is having straight flight without landing. Okay, that is more than 12 meter. So what you have to do is, in the description, you have to use the word exceeding and not exceeding. For example, you write here 12 mm diameter, high tensile. This is the example how you want to write description. High tensile, straight and bend bars in staircase. Okay, now you can write the length, or you can write here with length that is exceeding 12 meter, not exceeding 15 meter. That is the meaning of stages of 3 meter. Okay, class? So if you look at my description, my example, all the components have been written. You can see here the diameter, the type and kind and quality, high tensile, straight and bend bars means the texture, location as what have been shown in F.8.4, and then this one in case the length is more than 12 meters, so you have to write down in the description. Okay, and SMM also highlight the category where the bar, if you have vertical bar that is sloping more than 13 degree from horizontal, you have to also write in this category. But vertical bar here is may not be applicable for the staircase because this is normally referring to the racking board pile. Okay, if you refer to the, if I'm not mistaken, the last topic of your drawing in measurement 1, you can see the bar reinforcement is installed. Let's say this is your board pile in racking. Racking means a little bit slanting. Okay, so the bar that is very deep installed inside the ground, but that is more than 12 meters, so you have to write in category by writing the stages. Okay, this is in theory, principally this is how it looks like. So I give you one example. Normal building, normally you don't have this category that is more than 12 meters. Normally if you scale, even in your drawing, if you scale, you get about 3.4 meter, 5 meter, maximum is about maximum is not more than 12 meters. So you don't have to write this category. But in case you handle any project or I give you another drawing where the length is more than 12 meters, so please take note. Okay, Yong Chun Yu, Teo Binzi, understand? This is the principle of measurement for the bar reinforcement. Okay, Sharon, any question? Okay, this is the example where you can see the drawing, the layout plan in AutoCAD. Okay, where you can see the dimension of the landing slab. You can see the dimension, this is the landing slab. You can see the width of the staircase. This is the example. Why this information is needed? Because later you have to know how to get the length, how to get the measurement for the length of the bar that is laid like this. So when you need to measure, you need to know the width of the staircase and you have to deduct 2 concrete cover here. So all this information are needed. That means you still have to refer to drawing number 1, layout plan, section drawing in order to measure the bar reinforcement. Okay, and this is in 3D how it looks like. The detail that is suitable for the stairs of the span up to 16 feet. Okay, this is 16 feet. And then this is the example of the design where you can see overlapping of the bar reinforcement inside the landing slab and inside the staircase. Normally, you can see the word, sometimes they put the word C/C. Anyone know what is C/C? C/C means center to center, or sometimes they use the short form, engineer use the short form CTRS, means centers. Okay, so if you are given, for example, let's say I give you one example. Let me change color to, okay, I use the example of T10 dash 250. Sometimes you only can see 250, or sometimes you can see engineer put like this, center to centers. Okay, that means every 250 mm center to center you have one bar. All right, this is the drawing that you can see in your studio work or drawing number 1. Okay, now what I would like to do is, can you make some correction? Okay, I think this one is not really clear. Please take note that there are a few corrections that need to be made in your drawing. Please make sure that you change this one to Y12 250, because if not you will get confused. And this is the activity that also you have to do before you start the measurement for the bar reinforcement in your studio. What I would like my student to know first is, look at the green color. What you have to do first is you have to identify the bar reinforcement in the landing slab. Okay, after you identify the bar reinforcement in the landing slab, you have to identify the bar of the landing slab here in this drawing, and then I would like the student to highlight, okay, which one and which category. And you can see in this blackboard, you can highlight in different color. So let's say I ask Yon Chun Yu, can you highlight the bar reinforcement in the landing slab, the first category? So maybe you can start. Okay, Yon Chun Yu, you identify the bar in the landing slab. Okay, this is the first one. 1, 2, 3. You can see the shape. Okay, let's say the second one, I would like Engkau How to identify. So Engkau How identify the bar reinforcement for the bottom bar like this. Okay, so that is the first activity that all my students need to know. And you need to double check the bar reinforcement in the landing slab first before you go to the bar reinforcement in the staircase. Then only you go to landing beam. Principally, we identify the bar reinforcement in the landing slab first because you are given the detail of the bar reinforcement in the landing slab. Okay, look at this. This is what I did mention before, 2006, 2006. So now, can everyone refer to this drawing, drawing number 2? Can all of you refer to drawing 2.0, DWG 2.0? Okay, if you look at this drawing, okay, I would like you to take note that the bar reinforcement in the landing slab have similar category but different spacing. Look at this. Number 1, Y12 250. Number 2, I use different color, Y12 150. Okay, what is the difference between these two? Okay, in the landing slab or in any slab, if you have bar reinforcement, normally you have top bar and bottom bar. Please take note on that. Top bar and bottom bar. And in this case, if you look at the first one, there is straight, and you also can see bullet. Okay, they are having different category. If you look at this one carefully, the red color, this one is the bar that is horizontal. So you have the bar that is top and here bottom. Okay, the second one in blue color, you can see the blue color is here. So the blue color also is available in top bar and bottom bar. Can you see that, class? Okay, so that means if I refer this one to this layout plan, okay, this is for you to understand first where is the bar reinforcement. Where is the bar reinforcement? Which one is here? Let's say I use green color. This is green color. Okay, and I put this one as A. I put the blue color as B. This is for the student to take note, yeah, so that during the discussion in the studio, this one will be easier for you to do the exercise. Okay, now, can you tell me the green color now is belong to A or is belong to B? The green color. Now you are referring from this angle, right? You are referring to this angle. Now the green color is A or B, class? The green color is A. So if I change using the color either blue or red, this one should be red color. Can you see that? Okay, so the other one is blue color. So the blue color is actually laid like this. Okay, so that you can get something like matte. That is the bar reinforcement where you have the term is transverse bar. Okay, one is the horizontal bar, another one is transverse bar. Transverse bar is the bar that is laid 90 degree. This one. One is horizontal bar. Another one is transverse. Transverse. Transverse bar. That means at the end you can get the bar that is installed like this. Can you see that? Okay, so if you understand this one, okay, when you already identify this A is green, the A or the green originally is A, that is red color, and the second one is blue color, that is B. you have to look at this information and identify in drawing number 1. Okay, so now you can take note, yeah. A is Y12 250 and B is Y12 150. So if you have the hard copy, you can take note and write down. Is it okay, class? A is Y12 250 and B is Y12 150. Okay, then you have to identify and look at the details in drawing number 1. Can you see that? With the different spacing, this is A, this is B. Okay, if you see the bar that is A here, that is horizontal like this, in this angle, this one should be bullet. Is it similar, class? Can you see that? So in this case, okay, I highlight again the green color. This one is A or B? Y12 250. This one is A or B. Can you see the difference? Okay, let's see the first one. Y12 250. Now this one is belong to A. Okay, so this one is B. It is actually in different way. Okay, if I draw in 3D, it should be this way. Can you see that? Oh, sorry, wrong color. So this one should be, I write again. Okay, this one should be A or B? This is A. So A in red color, this is A. This one should be B. Okay, remember A is red color. So I draw in this one. So in terms of repetition, every 250 you have something like this. Okay, so B just now we have blue color. So blue color is this one. You have to repeat all of this until you reach to 2600. That is how you identify the bar reinforcement that is belong to landing slab. Okay, and then from this drawing you can see both are having different category. That means half of the bar is going up, half of the bar is going down. Okay, you also have to apply this one again for this one. So you know that the bar that is like this and like this is the bar that is going up. Okay, the other one, the bar like this and the bar, sorry, like this is the bar that is going down. Can you see that? This is going up, this one is going down. Okay, we will do this one in detail in terms of the discussion later. But firstly, what I would like you to understand before we go to the studio work, you have to identify which one is belong to the similar category as shown in the section view and as shown in the section view for the staircase. So you know that the bar reinforcement is overlapped inside the landing beam and inside the staircase. Okay, the bar reinforcement that is belong to the landing slab is it overlap inside the landing beam for this one and also inside the staircase. So the rest of the remaining other than this one, other than what had been highlighted here, that should fall under the category of the bar inside the staircase. Okay, so if I summarize in terms of item to be measured, you can see number 1, measure the bar inside the landing slab first. Okay, so the remaining bar that is not been measured yet inside the staircase should belong to the bar inside the staircase. Remember, when you identify this, you still have to identify the bar reinforcement according to the different size and different location. Location means landing slab, staircase, and the beam. Okay, and in landing beam also you have to identify according to different sizes and different type. Any questions so far, class? Any questions so far for the bar reinforcement? Okay, let's look at this example. State 4 basic rules or steps to identify and writing taking off list for the bar reinforcement. This is what I did mention earlier. So number 1, before you do anything, you have to identify the category based on Y or T. Okay, after you identify whether it's high tensile or mild steel, what you have to identify, class? You know that this is high tensile. You know what this is steel. So what is the second rule, Farah? What is the second rule before texture? The diameter of the bar. Diameter of the bar. And after you identify the diameter, then you identify the texture or the shape. The texture or the shape. This one based on F.8.5 in your SMM. And then last one is based on location. This one is based on F.8.4. But if you look at 0.4, you have a lot. A, B, C until, if you look at F.8.4, you have A, B, C until J. So what you have to refer is F, that is in step, staircase, and the string and associated landing. That means it's under one clause or one category. So this is the summary on how you identify the bar reinforcement taking off list. You identify this, then it will be easier for you to measure. Okay, look at the bar reinforcement in this photo. This is what I shared with you before. Look at the bar that is pink color. The pink color here is overlap from the staircase to the landing slab. And you can see that some of the bar is going up, some of the bar is going down. That is for overlapping purposes so that you have good connection between the structure. Okay, this is the summary and how you want to write down the description letter. Why I put the high tensile as the heading? Because you don't have to repeat. Let's say you have 4 items to be measured under high tensile. So you put this one under the heading and the description. You can write 12 mm diameter, straight and bend bars in landing beam. So you can see here how many rows. 1, 2, 3, and 4. The type in terms of kind and quality, the size in terms of the kind and quality as well. If you have more than shape, you more than circular shape, you have to write down. And then F.8.5 in terms of texture and location F.8.4. Okay. How you want to measure? This is only one example. This is the example where the bar reinforcement is like this. The bar reinforcement of the beam is like this. So let's say you are given that the length is 1.4, then the concrete cover is given as 25 mm diameter. So you have to deduct 2 times 25 mm diameter, you get 1350. But remember, let's say in this example, you are given the formula for all bend in the beam. That is 90, so you have to add it 90. But remember, you have 2 bend. If I draw again, maybe I can draw again. You can see something like this. Okay, the length of the beam is 1400, 1400. The concrete cover is given as 25. So you can see here, maybe this is 25, this is 25. But the drawing is not to scale. All the specification already state, okay, for all band, the formula is 90. So you have 90 here, and you have 90 at this side. That's why you have to add in 2 times 9D. D is formula for, D is the diameter of the bar reinforcement. So at the end, you have 1.56. Okay, this one I have to correct as well. Please make sure that the length is only in 2 decimal places. 1.57. Then times 4 because we have 4 numbers of the bar. Logically, the bar reinforcement in the beam has the minimum of 4. Why I say minimum? Because sometimes you have more. Okay, so minimum of 4 means you have 2 on the top and you have 2 at the bottom. Okay, this is one example of the calculation. And then this is what I would like you to highlight, and you have to take out the design and put in the side cast. Okay, for example, this is the bar reinforcement of the staircase. So if you look at this, for example, the design is this way. Look at the black color. And you have to scale in every single shape. Okay, let's say this is 100, this is 350, 1006, and 400. I would like to see all these ways of writing or method of writing properly shown in the dimension paper. For this task, I don't want to use reinforcement sheet yet. I only want to see all the answer in the dimension paper because the way you need to get the answer is actually more important than the final answer. So all the tasks for the studio number 3 by reinforcement must be only shown in the dimension paper. That means you have to show this sketch and we have to show all this level. I did not encourage or I don't want the student to write A, B, C, and D. I rather prefer to see that you write down this length straight away. I see that some of you may write this one is A, this one is B, this one is C, and this one is D. So in your right hand side of your dimension paper, you write here A, B, C. No need. You have to write the length straight away in the side cast. Then here, write again. Then you get the total length. This is what have to be written in the dimension paper 2.45. Then you count how many numbers. Let's say 10. Then I can see the answer. So the final answer can be converted in the last column of the similar category. Okay? Ling Wenjin, any question? Okay. This is the example of the bar reinforcement description, but this is inside the staircase. So look at this. This is what that must be shown in the sidecast. And actually, if I put the sketch again, you have to show all of this and put all the label. Okay, something like this. Put all the label so you get the final answer here. Okay, the numbers of the bar, this is only one example. Let's say you get the width of the bar, the width of the staircase is 1400. 1400, then you deduct 2 concrete cover, you get 1350. But because the spacing is given as 200, so don't forget to add in another one. This is the basic formula for you to get the numbers of the bar. Please add another one. Then I also would like to highlight how you want to write by rounding up. Okay, look at this. For example, you get 6.75. Please use this symbol. This is actually a symbol of rounding. 6.7 is equal to 7. Then only you plus 1. Do not do 6.7 plus 1. You have to round first, then plus 1. So this is the correct ways of writing. You get 8 numbers later. Right, that will be the end of the measurement for the bar reinforcement in terms of the discussion for the theory part. Any question, class? Any question, class, before we end? Any question for the bar reinforcement?